demonstrate Newton's first law of inertia. Would you look at that? It's beautiful.
First things first. Objects in motion remain in motion. Pretty simple. Now, of course, this one didn't remain in motion because the screws served floor. It's actually kind of sticky. But theoretically, if we were an endless and smooth vacuum full of literally nothing, I could have just touched it and it would have gone on infinitely. But it didn't, because that's not real life. Anyways, moving on. Now we're on to the second part of Newton's beautiful first law. Inertia. Well, an object at rest remains at rest. As you can see, this beautiful little stick of this beautiful stick of chapstick has yet to move again. That is because objects in rest remain at rest unless otherwise prompted by a very mean outside force. A beautiful contrast.
Hi, my name's Diego Pedraza, and I'm going to be talking about Newton's second law, which is F equals ma. And I'm going to have 3 examples that will help demonstrate how the law works. But basically, the Newton's second law explains that the more force you apply into an object, the more acceleration it will have. And the heavier the object is, the less acceleration will it have. So basically, more force will be needed to make it faster. Now, the first example are these 2 little cars right here. So I'm gonna push this small one, and I'm gonna use the same force for both of them. So here's the first one. That was pretty fast. Guys. All right, same force for this one. He barely moves. Barely. See, the truck or the 18-wheeler had more weight than the little small car. I'm gonna use more force on one time than the other. All right, so look, small push. Now I'm gonna use a big push. So he went fine. The different planes, so the X plane and the Y plane. So horizontally, with the ramp, it's gonna roll down and it's gonna have much more acceleration. Basically, what that showed us was that gravity was pulling it down that was a Y plane working, and the X plane had no force. So basically, each direction has a different acceleration because each direction has a different force.
Newton's third law of motion. This law is also known as the action-reaction law, which states that for every action, there is an equal and opposite reaction. We've already established that a force is either a push or a pull. So with Newton's third law of motion, we can conclude that neither a push or pull can occur on its own, but rather it happens because 2 forces act upon it. For example, when you push against the wall pushes against you as it has no movement. This law of motion is a physical phenomenon, as it explains the physical reality in which objects exert forces on one another. Furthermore, this means that in every interaction, there is a pair of forces that act on the 2 interacting objects. Therefore, the direction of the force on the first object is always opposite to the direction of the force on the second object. Another example of this would be simply walking. During this, your foot pushes backwards against the floor, and the ground, in turn, pushes forward on your foot. The force is equal to which propels you forward.